Okay, calculus people, here is your riveting solutions video for this practice quiz related to derivatives of exponentials and logarithms. Here we go. Number one, we're looking at e to the x, and you need some chain rule here, so e to the u, e to this piece here, and then u would be 5x. Find the derivative of y, and that's just, the cool thing is it's just e to the u, and we've defined u as 5x. There it is. The derivative of u, use the power rule, 1 times 5 is 5, reduce the exponent, just 5. Then, chain rule means multiply those two. So e to the 5x times 5, I'm going to put the 5 in front as kind of the coefficient, 5 times e to the 5x. Number one, done. Let's check out number two. I'm going to let y equal 4 times the ln of u. And so it's like this constant again, like that multiplier is just affecting the slope, so it's not really affecting the derivative other than multiplying at the end. And u is the inside function, is the x squared. So y prime equals 4 times 1 over u. Okay, so the derivative of natural log is 1 over x. And then insert, instead of u, I'm going to put in the x squared, which we could write as 4 over x squared. U prime, 2x. Then multiply those two. 4 times x squared times 2x. Do some simplifying here. I got 8 over x squared. Let's factor out, or let's divide out an x in top and bottom. Your final answer, best answer, is 8 over x. Number 3 has a similar process. Got the constant out there, and I have the base of 4 raised to easiest to differentiate when I've got like just some one singular variable. So I'm going to chain rule it. Derivative of, so the multiplier, ln 4 times 4 to the u, and u is 3x. U prime is 3. Multiply those, gather your like terms. I'm going to take negative 2 times 3, make negative 6. And natural log of 4 is just a number, times 4 to the 3x. That's it for that one. This special problem is going to add in the product rule, because I've got 5 to the x times the natural log of that chunk. So let's let u equal 5 to the x. Switch up the color without being too distracting here, hopefully. And then v will be the natural log of, and I'm gonna kind of chain within chain here. So I'm gonna make this like w, because that's a cool letter. And then w equals 2x cubed. Okay, so I'm still looking at u prime v plus v or u v prime, and so I'm just going to have to chain rule within the chain rule for that second one. But we'll get to that. So back to black here. Do u prime, which is natural log 5 times 5 to the x, and v prime, I'm going to have to chain together, so this derivative, 6x squared, times the derivative of that, which is 1 over 2x cubed. So I chained it together. I first did the inside function, the derivative of 2x cubed, power ruled that, and then found the derivative of the natural log of the inside function. Simplify that, I end up with 6x squared over 2x cubed. 6 divided by 2 cancels to make 3, and I'm going to have an x in the denominator. Okay, now do your u prime v plus uv prime, the product rule. So u prime is natural log of 5 times 5 to the x times v, which is the natural log of 2x cubed, plus 5 to the x times 3 over x. Now we can clean that up a little bit. We could factor. I think you could. The first step might be you could do this. This would be a really nice thing to do. If you got here, this is great, but you could put this. Actually, I lied. I think if you're here, you've got your understanding. If you want to factor out something to make it a little cleaner, look for what those two terms have in common, and all I see is a 5 to the x that both terms have. So I might factor that out. I'm going to put that on the outside, parentheses, plus what's left is natural log 5 times natural log of 2x cubed plus 3 over x. I think that's a nice clean answer right there. Let's clean this up just a bit more. Last one. It's a quotient rule kind of situation. So set up top function to the u essentially, because I'm going to have to change. All right, let's make that a u. Let's make that w. And w equals x squared. So I'm going to kind of chain those together for the top function. Then deal with the bottom function. Then do the derivatives. Oh, love that derivative. E to the x derivative is e to the x. This function, I'm going to do 2x. So the derivative of this times the derivative of 2x squared, which is going to be ln 2 times 2 to the x squared. Okay, let me double check in my work here. And I probably will reorganize. I'm going to reorganize this before I go. I'm going to say, okay, constant. So I got 2 ln 2 times x times 2 to the x squared. All right, now, quotient rule. U prime v minus uv prime all over the bottom function squared. So u prime is 2 natural log 2 times x times 2 to the x squared. Ooh, that's a nice one. Times v, e to the x, minus 2 to the x squared, original function, times v prime times e to the x, all over e to the x squared. If you're there, that's great. I'm going to factor it, go one step further in just a second. In terms of factoring, if you want to go there, I'm looking at two terms have an e to the x, so I'm going to pull that out front. So that leaves me with 2 natural log 2, oops, no parentheses, times x, yes, parentheses, times 2 to the x squared, minus, oh, nope, pause video. There's another piece they both terms have, and that's a 2 to the x squared. So those both factor out, leaving me with 2 ln 2 times x in the first term minus 1 in the second, all over e to the x squared. Now, guess what? Well, e to the x squared is e to the x times e to the x, and now that I've factored out the e to the x, one of those will cancel out. So, 2 to the x squared times 2 ln 2x, just a number, times x minus 1, all over e to the x. Any combination of these, I'm feeling happy that you got. Email me if you got further questions.